Hi, and welcome to openIMIS Developer Training Sessions. This presentation serves as an introduction to openIMIS development and is dedicated to give you a broad overview of the software internal architecture. It will identify the various parts of the software, the base principles they follow, and how they interact. With this big picture in mind, you'll be able to navigate through the other training materials which address each part individually. But first of all, the reference documentation for openIMIS software is the wiki. The wiki is updated along the software lifecycle, so don't hesitate to consult it for more detailed and up-to-date information. The agenda for this session is to first describe the architecture conceptually, so which are the main ideas behind, and then have a quick look at the technologies that are used to put this architecture in place. openIMIS is a classical three-layers software. So it's made of a database layer, which is a relational database with enforced constraints. We do use foreign keys, unique keys, mandatory columns, and all of that. The backend or service or API layer is a modular and transactional application. So we are not into a microservices architecture. The frontend layer is modular and based on components. Both backend and frontend follow two major principles: contributions and events. Let's first have a look at contributions. Contributions are dedicated to prevent modules to require a deep knowledge of each other's. So for example, in the backend, but it's the same way in the frontend, in the claim module, if you want to search claims based on insurer last name, so we are in the claim module, but we are using a characteristic of the insurer which is part of the insurer module. So without contribution, what we would be doing is to create an additional method or API that allow clients to search for claims based on the insurer last name. And within the claim module, we do whatever is needed to filter the claims based on the insurer last name. So in this example, we see that the claim module knows that an insurer has a last name. So if one country requires also middle names for the insurers and want to search claims based on the middle name, we would have to adapt the claim module because of a characteristic of the insurer module. So to avoid this, we use contributions, and with contribution it would look like this. So the claim module will still have a search on insurer, so there is no doubt a claim concerns an insurer, but the resolution of the filtering on the insurer details are performed by the insurer module. So the insurer module contributes to the claim search criteria and inject whatever criteria is available in its implementation. So if the country has a last name for the insurer, it will search on last name. But if now we have to add a middle name, it's in the insurer module that we will be doing the change. The claim module would stay the same. Let's have a look now at the second major principle within openIMIS architecture, which are events. With events, modules don't call each other straight, but they publish events and the other modules may react on those events. So it's the exact same principle as the microservices architecture, but here it's used internally. So this allows us to have event processing within openIMIS within one single main transaction, or to detach the processing of the events to an isolated transaction if needed. Internal events may also be published outside openIMIS via an ESB or such technologies. This makes openIMIS also easy to integrate with microservices-based solutions. Let's have an example. If we want to send an SMS to an insurer when a claim is rejected and we don't use events, what we will implement is in the claim service, when we reject a claim, we will update the claim status, but then we will send the insurer SMS. So in this case, the claim module knows that the communication with the insurer is via SMS and that the insurer has a phone number to which we can send an SMS and so on. So this makes a tight coupling between the claim and the insurer details. What we will do with events to prevent this coupling is to, of course, when we reject a claim, update the claim status and do the claim calculation that are needed. But then we publish an event that says there is a claim that has been rejected. And the insurer module will listen to this claim rejected event and depending on its own internal logic, but in this case it will send an SMS to the insurer. So if tomorrow the communication with the insurer is via email instead of SMS, we just have to change the way we handle the insurer communication without having to change anything in the claim module. Programming with contributions and based on events provides a lot of flexibility, but it is also much more challenging and requires more time than traditional or more straightforward programming. It requires you to think twice about what is in the module scope and what belongs to the other module. When exchanging information, we have to hide some details, so provide some more generic way of communicating between modules. And of course, every taken decision may be reviewed afterwards, so requiring a refactoring of your code. Let's have a quick example. If alerting the insurer on claim rejection is an important or mandatory step of the claim processing, you may enforce the communication in the claim module, so keep that responsibility within the claim module. In that case, when a claim is rejected, you update the status as usual and you enforce the alerting of the insurer. The way the alert is performed is still within the insurer module, but it's enforced here from the claim module. Obviously, you can still publish the claim rejected event so that other modules can react on it. Later on, you may realize that communication requires more flexibility and justifies the creation of a dedicated module. So in this configuration, the claim would still only publish an event, but the responsibility of the communication module is to react on the claim rejection event and enforce the communication to the insurer. Contributions and events are also the cornerstones for country customization. So if in your country you also need to alert the payer on claim rejection, what you would be doing is add an external module, so a new module that also listens to the claim rejected event but alerts the payer on top of the insurer. Reaching the right level of genericity and extensibility is not an easy task. But openIMIS is much more than a software, it's a community. So please don't hesitate to come to our regular meetings and talk with us about the extensions you plan to do and how we can make them profitable for everybody. So to sum it up, openIMIS is a three-layer software with the data layer into a relational database. The backend layer is based on events between modules and contributions for the API, and the front-end pages are assemblies of contributions in the same way as the backend. Let's have a quick look at each layer individually. The database layer is today based on Microsoft SQL Server, but there is a running migration to target PostgreSQL. Along with this migration, we will keep the constraints of foreign keys, unique keys, and so on, but we are going to remove the computing logic, which is today in the store procedures. And we are going to place it into the backend, which is based on Django. So the database, the SQL, will be queried from the Django ORM object relational mapping, and we will not write SQL anymore in the backend. In the same way, the data model will be managed by Django migrations. So when we update the Django model, Django will apply the changes into the database layer. And we also use JSON fields for extendable objects. So today the JSON fields are simple text fields in the MS SQL database, which are processed via JSON functions of Microsoft SQL. But in Postgres, we are going to switch to JSON-B fields to have full feature JSON fields for extendable objects. The backend layer is based on Django framework, so models and services are written in Python. The default API for modules is following GraphQL standard and is implemented using Graphene Python library. This includes queries and mutations. Queries are synchronous, so whenever you search for claims based on insurer last name, you receive the list of matching claim as response to your call. The mutations, so the creation, deletion, or update of object, are asynchronous. So the backend records the mutation and returns an identifier to the caller, but the processing of the mutation is performed in the background asynchronously. Other APIs are possible for the modules, but they are implemented as additional module. This is the way the Fire API has been implemented. Events in Django are called signals, and Django allows us to fire signals everywhere. However, we should not use signals at low levels, such as database entities update, and only emit signals with a relevant business meaning, such as claim rejected. Indeed, for example, when a claim is rejected, maybe several database entities gets updated. So if signals are fired for each update, we end up with too many signals being emitted and poor performances. The contributions mechanism is not there by default in Django and Graphene, but is enabled in openIMIS with a specific way of dynamically assembling the GraphQL schema. Finally, we recommend using virtual environment to fully control the technical dependency of your development in openIMIS. For the front end, so the user interface, we are using React and Redux JavaScript frameworks. Contributions mechanism is not provided by default in React, but is openIMIS specific. Events, on the contrary, are implemented using the default Redux dispatch reducer mechanism. Modules are built with Rollup, and the full application is assembled with Webpack. We also recommend you to use Yarn, but it's not mandatory. There are many resources available on the web for the various used technologies. Here is a quick list to get you started.